Okay, so this is the BGP policies in Superlab 1. Now there's an awful lot of policies that we want to be attaching to our external peers here. And so what we're going to do is we're going to look at all of the AS paths, all of the communities and all the policies. And once we've worked out how they all work and we've checked them out, then we're going to go through peer by peer and deal with them one by one and attach all the policies. So let's just have a look. This is Superlab 1. Let's see what we've got here. So these are the communities that we're going to be using. We've got a community customer, which is going to mark all the customers. Obviously, the members there are going to be, from our AS, and it's going to be 200. We've got a community for peer. So for the upstream peers, the members there are going to be 100. We've got the wildcard. Members there are going to be ***, which is all of them. We've got routing to black hole, and the members here are going to be 6451 and then a dot, and that will match all the individual ASs of the customers, and that's going to be the 3 6s. Of course, no exports, well-known community, we still have to define it, so the members there will be no export. These are the paths we're going to be using in the policies as we put them up. We've got P1 IPv6 foreign. The idea here is that it's any path from of IP version 6 style from peer 1 that's longer than 2 AS hops. It means obviously that it's come into peer 1 and then would be going out. We've got here P2 neighbor, and the number here we've put in the decimal, standard decimal, so 65536 times the first number before the dot, add the second number, you got the thing. Or you could put it in the 4-byte style, you just need to escape the slash. Okay, we've got AS path prepend, got a little prepend there of 3 times our main AS. P2 native is literally just the number of the P2 autonomous system, again multiplied out. P2 long path is basically 6 hops or more, so more than 5, and it's the same style there as the 2 hops on the IP version 6. We've got P1 neighbor, and this can be any path that's coming through the P1 neighbor. So these are routes from the P1 neighbor. They can be transit routes. We can block them, allow them. Okay, let's have a look at the policies. So set policy option, policy statement. This is next hop self. This is an IPv4 next hop self. So simply from protocol BGP, then next hop self, then accept. Here we've got local range from route filter 172.16.00/16 exact, then accept. Here we've got eBGP import filter. We've got 3 terms here. So from route filter 0/0 up to /7. Now this is any route with basically a length of up to 7. So that would be a supernet. Then reject. The next term from route filter 0/0, this is prefix length range from /25 to /32. And what we're really saying here is any route with a prefix length range longer than 24. So that would be the longer routes, and again that's a reject. And then finally term 3 from route filter 0/0, and in this case it's through 0/32. So that's following the path of the tree there, and that's basically any default route. So any kind of default route, any length, and that's going to be blocked. And reject. Here we've got delete communities. So we use this for cleaning the communities off the routes as they're being exported. So 1 term from protocol BGP, then community, delete wildcard. And as you know, the wildcard is ****. When we delete that, it wipes all the communities. Okay, let's have a look up here. Set policy options, policy statement, no P2 routes, export. So what we're doing here is from protocol BGP, from AS path, P2 neighbor, then reject. We can see the P2 neighbor over here in its decimal form. Here we've got eBGP IP version 6 import filter. So what's happening here? Well, from AS path, P1 IPv6 foreign, then reject. We're trying to take the transit routes out of the IP version 6, and what we've basically done, we've called it foreign, and it's any route with 2 or more AS hops. It means it must be a transit route. No export routes, it's well known, but we still have to define it. And P1 preference, This is quite nice. Term 1, then local preference 150, and that's a little preference already for applying, in this case to peer 1, but that could be applied somewhere else. And then finally we've got black hole. So from protocol BGP, from community routing to black hole, then next hop discard. And that one is an iBGP policy, and it's an iBGP import. And then that way, when a router receives that from a customer, a PE receives it from a customer, it will actually send it out the iBGP, and then the other PEs grab that and apply it inbound, and that means everyone gets it. So that's the way to black hole the routes there. And what we're going to do next is we're going to look at the peers one by one and how all these policies and AS paths apply.